I got. All right, no problem. I'll repeat it again. So the question, first we have to look at the question. And it says that the random sample of size n were selected from a population with a known standard deviation. So we know the standard deviation. How is the standard deviation of the sampling distribution affected if the sample size is increased from 50 to 200? So they're saying, how is this affected? How is this affected? So when we have a size of 50, our standard deviation of the sampling distribution is going to be the population standard deviation divided by 7.07. Okay? When n is 200, our standard deviation of the sampling distribution of the sample mean is going to be our sample or population standard deviation divided by 14.14. 14.14 is basically 7.07 times 2. So you can put in your calculator, it's 7.07 times 2. What they were asking us is, how would the sampling distribution, how would this be affected by increasing the sample size? So we're going to now be dividing by 2. As I said right here, so we're dividing by 2 times the root 50 because root 50 is 7.07 and 7.07 times 2 is going to give us a 14.14. So that's why I say it is divided by 2. All right, no problem. All right, question 15 now. Let x be a random variable that has a binomial distribution with mean 12 and a standard deviation 1.5. Based on random samples of size 400, the sampling distribution of the mean is A, highly skewed with mean 12 and standard deviation 1.5, slightly binomial with mean 12 and standard deviation 1.5, C, approximately normal with mean 12 and standard deviation 0.0375, and D, approximately normal with mean 12 and standard deviation 0.075. What's the answer, guys? So guys, remember, you know, if they have the answer sheet, you still have to understand how we come by a certain answer. So when you get the exam, you can reason it the same way. So, firstly, changing any distribution to a sampling distribution makes it become approximately normal. That's the first thing. So the first thing is that changing any distribution to a sampling distribution makes it become approximately normal. That's the first thing. Remember that the mean for a sampling distribution is the same as the mean for the population. Remember that? So the mean is the same for the question. So our answer is between C and D. So now we have to solve for standard deviation. Remember, we have a formula for finding the standard deviation for the sampling distribution of the mean. And the formula is that the standard deviation of the sampling distribution of the mean is equal to the standard deviation of the population divided by the square root of the sample size. We know that the standard deviation of the population is 1.5 and our sample size is 400. So 1.5 divided by 20 is equal to 0.075. So the answer is D. All right, once more. So the question said, let x be a random variable that has a binomial distribution with mean 12 and a standard deviation 1.5 and a standard deviation 1.5 based on a random sample of size 400. The sampling distribution of the mean is, the first thing is this, we are changing our distribution to a sampling distribution. So the first thing that you guys should note is that when changing any distribution to a sampling distribution, it makes it become approximately normal. So remember the third characteristic of sampling distribution was that the distribution of the sample mean is fairly symmetric. And we know that if something is fairly symmetric, it means that it is approximately normally distributed, or it is normally distributed. That's the first thing. Remember also, when we were learning is that the sampling mean, the sampling distribution of the mean is equal to the population mean. Remember that mu x bar is equal to mu. So in this case, our mean was 12. That it means that the mean for the sampling distribution is also going to be 12. So first is going to be approximately normal with a mean of 12. So now we have to solve for the standard deviation. Remember that the standard deviation for the sampling distribution of the mean is given by the population standard deviation divided by the square root of our sample. All we're going to do now is to plug in our values. We know that our population standard deviation is equal to 1.5 and our sample size is 400. So it's equal to 1.5. You find the square root of 400 is going to be 20. So 1.5 divided by 20 is going to be equal to 0.075. Are you guys still lost? Or did you guys follow that? Joy, are you still lost or are you okay? All right. Amazing. So now we're going to be looking at central limit theorem. So if a simple random sample of size n is drawn, so basically what we were doing a while ago is a central limit theorem. So if a simple random sample of size n is drawn from any population with mean u and a finite standard deviation, when n is large, the sampling distribution of the sample mean x is approximately normal with mean mu and a standard deviation. So what we did a while ago, so you guys see, what we did a while ago was based on the central limit theorem. So if a simple random sample of size n is drawn from any population with mean mu and a finite standard deviation sigma. When n is large, the sampling distribution of the sample mean x bar is approximately normal, with mean equal to mu and standard deviation is equal to the standard deviation of the population divided by the square root of n. So you guys see now how the answer for 15 came about. It's based on the central limit theorem. You guys good? You guys good? Guys, are you guys talking to me? Communicate, please. So we're going to be focusing on phrasing. So there are two types of distribution that we can use. All right. So there are two types of distribution that we can use. So when we're using normal distribution, when we did our second mid semester, it asks what is the probability that A. So if they ask us what is the probability that A, we know that we're dealing with the probability distribution of a random variable. And the formula is Z is equal to X minus mu divided by the standard deviation. All right? If they ask you know what is the probability that the sample average or mean is, then the sampling distribution of the mean, this is represented by, this is known as the sampling distribution of the mean. And Z is equal to X bar minus mu divided by the standard deviation divided by the square root of n. So the probability distribution of the random variable is normally dealing with a population. And why I say a population? Because there is no n. We don't have to account for the sample size. All right. While the sampling distribution of the mean, you know, we're dealing with some form of statistic and a sample, so we have to account for our sample size. So you guys have to. So Miss might ask you a question. In order to maybe she asks you which one, what type of distribution is this question represented by? Once you don't see anything about a sample average or just an average or the mean, you're dealing with the probability distribution of a random variable. Okay, guys? Okay. So we're going to look at a question now. Joy, what exactly do you want me to repeat? You can speak into your mic. What exactly do you want me to repeat? Ask me a specific question.
Well, I just wanted to repeat what you were saying just now about if the question doesn't says that it is if you get what I'm saying.
If the question doesn't say